see this one? Logarithmic. Okay, logarithmic function. Okay. How to define this function? If we have an equation, which equation? E omega power equal z. Okay, E omega power equal z, and this z you have known, but this omega you don't know. So from this equation, you want to find omega. How to find omega? It's easy because this z you have known. So you can write z equal x plus iy. And you can also write z equal r e I theta. Do you remember? This r is the modulus of z. This theta is one of argument of z. You can also take the principal argument of z. All is okay. Okay. If this z you have known, so this r and theta you have known. Okay. So we want to find omega in this equation. We can set omega equal u plus iv. Okay. If you can find u and v, you have found omega. So now we want to find omega. So now we first find u and v first. Okay? Find u and v first. How to find u and v? We take this omega into this equation. We take this z also into this equation. Okay? So we can obtain, here is e u plus iv. Okay? And the right side is r e I theta. Okay? So in the left side, you can write EU multiply EIV. Okay. On the right side, you also write REI theta. You know, this U, this V, this R, this theta, all of them is real number. Okay. So this one equals this one. You can find this one is the modulus of this omega. This r is the modulus of this z. If this one equals this one, so the modulus of this one equals the modulus of this one. So you can obtain two equations. The first equation is EU power equal R. The second equation is EIV equal EI theta. Yes or no? Don't know. Because this one equals this one.
Final machine. EU must be equal to R I theta over EI.
No. Because this EU is the modulus of omega. This R is also the modulus of Z, not omega. EU is the modulus of E omega. Okay. Now you say E omega equal Z. So the modulus of E omega also equal the modulus of Z. So you can obtain the first equation. If this one equals this one, you can delete. So EI will equal EIC.
Then when you write that in their form, it cannot be equal to EU equal go to I theta over.
If you write like that, you can't find U. You also can't find V. You need to write like this one. Then you can find U.
But we don't
And
know
you
the
can
value.
find V.
We don't know the value of U.
You don't know U. U is don't know. V is also don't know. We only know R and theta. U and V is unknown. R and theta is known. Understand that? So now this U is a real number. This R is a real number. So in your middle school, you have learned this U and R is a real number. So you can write ln R. Listen up. Okay. Like because X and Y are real number. This R and U is real number. So you can write ln R. Okay. The second one, EIV equal EICT. Because if this is complex, this function is a if this z is complex, omega equal ez power is a periodical functions, and the periodical is 2k pi r. Why is this one? This is very easy. I can tell you. Okay. Why this number? Why this function is a periodical function, and the period is 2k pi r. Because omega equal ez power, you can write ex plus iy. So you can write ex cosine y plus I sin y. Okay. Because this cosine y and sin y is periodic. And the period is 2k pi. So this one you can write cosine y plus 2k pi. This one you can also write y plus 2k pi. Okay. So if this is EIY, this is EIY plus 2k pi. So this one equal EX plus IY plus 2k pi. So omega equal EZ equal EZ plus 2k pi r. EZ equal EZ plus 2k pi r. So this function is a periodic function, and the period is 2k pi r. 2k pi r. 1 is 2 pi I. This k can be, this k can be 0. And so up. So when k is 1, it's 2 pi I. Okay? So if you want to understand this one, you must understand this one first. If you understand that one, then I will teach this one. Okay? So please tell me, have you understand this one? Omega equal easy power is periodic. Have you understand? Okay. And all the period is 2k pi I. If you understand it, then we will continue. Okay? Okay?
So now this one here is that if this one is periodic function, then this one is unperiodic function.
Because omega equal easy power. This is the original function. Okay? But now we have obtained easy power equal this is z. So now we have obtained easy power equal ez plus 2k pi I. And this is a constant. If you can find a constant such that easy power equal ez plus 2k pi hour, then you can say this function is periodic, and this constant is the period. Okay? Understand it? Okay. If you understand this one, now we know. Because this is complex. This is also complex. So, EIV equal EI theta. You can also write EIV equal EI theta. And EI theta will also equal EI theta plus 2k pi. Yes. We use this formula. Use this property. Okay. So EIV equal EI theta. We may be equal theta. We may be also equal theta plus 2k pi. So from the second equation, we have obtained V is theta plus 2k pi. Understand it? Yeah. Okay. So now you have found U. You also find V. So you find omega. So from this equation, if E omega equals Z, this omega and Z are complex. We can obtain omega equal U is ln R. R is the modulus of Z. Plus I V is theta plus 2k pi. Theta is the one of the argument of z, then plus 2k pi. One of the argument of z plus 2k pi is all the argument of z. So now you can write this equal so we can also write omega equal ln z power plus I big argument of z. If E omega equal z, we can obtain omega equal ln z power, the modulus of z, plus I, the argument of z. And we define this value. We define this value is the logarithmic of z. We define this value is the logarithmic of z, but this L is big because this A is big. Why this A is big? Because here is the principal argument of z plus 2k pi. So you can take this one, big A, big A. So now you have defined the logarithmic of complex number. Logarithmic function of complex number equal ln the modulus of z plus I argument of z. And you can also write ln the modulus of z, the principal argument of z, then plus 2k pi r. So there are many values of this function. So there are many values of this function. But this part is unique. Because this one is unique. Because many values is here. Okay? So now, if z is complex number, which complex number you can compute logarithmic? Which complex number you can compute logarithmic? So you can see here. If E omega power equals z, so this z can't be 0. If this z can't be 0, this z also can't be 0. Except 0 or other complex numbers, you can compute logarithmic except 0. So now, according to this formula, this is very important. According to this formula, please compute three numbers. Okay? The first one is big L minus 5. This is the first one. The second one, big L. Okay? The third one. Okay? Please try yourself. Please compute these three numbers.
Masakan Another one. Well,